All right, so what we're talking about now is being able to solve two-step equations. So we looked at one-step equations, and we said that it took one step to solve. So solving two-step equations, what do you think we're going to do? Two steps to solve, okay? And we're still going to be applying those properties of equality and those inverse operations. Remember, addition and subtraction are inverses, multiplication and division are inverses. But I want to go back to order of operations for a second. So on the side, I'm going to write PEMDAS. Okay, and we talked about how, oops, there we go. We talked about in PEMDAS, this is applying the order of operations. We do parentheses, exponents, and multiplication and division from left to right, and then addition and subtraction from left to right, okay? Well, when we do the order of operations, this is the order in which we do things, okay? So when we apply the order of operations, this is the order in which we do things. Parentheses, exponents, multiplication, division, and then addition and subtraction, okay? However, we got to kind of get out of this mindset for a second, and we're actually going to work backwards, okay? We're actually going to work backwards, okay? So when we're solving equations like we're going to now, okay? Like we were solving one-step equations, now we're in two-step equations. When we're solving, we actually work backwards, okay? Oh, missed my V there. Go back. And you might say, well, Mr. P, why is it that we're actually having to work backwards here? Well, in a sense, we're undoing the order of operations. We're working backwards, okay? So the order of operations gets us to the end goal. Well, solving is I have a missing value and I have to undo the order of operations to get that variable by itself, okay? So instead of starting with parentheses, we're actually going to start with addition and subtraction and then work our way up the list. Okay, so let's look at some of the most common examples. Okay, so examples like 1, 2, 3, and 4, those are the most common types of solving two-step equations that we'll come across. Okay, so let's look at number 1. On number 1, I want to get n by itself. Well, again, we're going to do the opposite of what we would normally do, and instead of dealing with parentheses, exponents, multiplication, and division first, we're going to deal with any addition and subtraction part first. A good way to think of it is we want to deal with the number on the same side of the equal sign as the variable that is furthest away. So notice we're going to take care of this addition of 1 first. And what I mean by that is we need to move this number to the other side, okay? We need to move this number to the other side. Well, how did we do that when we were dealing with one-step equations? We did the inverse operations, correct? We did the inverse operations. So to get rid of this plus 1, the opposite would be to subtract 1. So we're going to subtract 1 from both sides, applying that subtraction property of equality. My inverse goes away, and I get 0 minus 1. Well, 0 minus 1, I get a negative 1 is equal to n over 8. Okay? So now, I've already taken care of my addition subtraction part. Okay, we subtracted 1 from both sides. Now we take care of that multiplication division part. And notice I have n divided by 8. Well, doesn't this look like a one-step equation? Yeah. After we did one step, now we're down to just one-step equation. So this is exactly like what we worked on with the one-step equations. How do I undo division by 8? Multiplication, right? But if I multiply 8 to this side for my inverse, I also have to multiply 8 to this side using that multiplication property of equality. So 8 times the negative 1, remember a positive times a negative gives me negative. In this case, 8 times 1 is 8, is equal to n. And we could check this. We could plug a negative 8 back in and check, okay? So in our original equation, we'd have 0 is equal to, if I plug in a negative 8 for n here, okay, a negative 8 for n, let's see if that comes out to be 0, okay? Well, what's a negative 8 divided by 8? Negative 1, right? And then a negative 1 plus 1? 0. So we know that we're correct here and that negative 8 equals n is our answer because we get out what we wanted in the original equation, okay? So now let's try another example like this. So looking at this guy here again, I'm kind of working in reverse here, and in fact, I want to deal with the number furthest away from the variable on the same side of the equation. Take care of this addition subtraction part first, okay? So we're going to deal with the 2 first, and what we want to be able to do is the inverse operation. So what's the opposite of adding 2? Subtracting 2. But again, I have to apply it to both sides, that subtraction property of equality. So I get rid of this, that's my inverse, and I'm left with r over 3 equals negative 1 minus 2, same sign, add and keep, 1 plus 2 is 3, and they're both negative. Okay, well now I'm back to my one-step equation again. I have r divided by 3. How do you undo division? Multiplied by 3. Okay, the opposite of dividing by 3 is multiply by 3. This cancels out, but if I multiply by 3 to one side, I have to multiply by 3 to the other side, multiplication property of equality, and I'm left with r is equal to, what's a negative 3 times 3? Negative times a positive is a negative. 3 times 3 is a 9. So my answer is r is equal to a negative 9. And again, we could check this, we could plug it back in. If I had a negative 9 divided by 3, that would be a negative 3, right? Well, what is, moving it up here, a negative 3 plus 2, is that equal to a negative 1? Well, yeah. So remember, different signs, we subtract. 3 minus 2 is 1. And we keep the sign of the larger value, which would be negative. Okay? So it checks out, and r equals a negative 9 is my solution. So that's 2 of the most common types you'll see. Now let's look at 3 and 4, the other types that are pretty common that you'll run into. Okay, so again, in this example, we want to get the variable by itself, but we work with the number furthest away from the variable on the same side, okay? Because we want to take care of that addition subtraction part first, okay? Now notice the 8 isn't being subtracted. I don't want to mislead you. The 8 isn't being subtracted. However, since it's a positive number, it's almost like it's being added to this side. So we can think of this as a positive 8 being added to this side. So how do I get rid of a positive 8? Do the opposite, and I subtract 8. So I'm going to subtract 8 from this side to cancel it out. But whatever I do to one side, I have to do the other, subtraction property of equality. And I'm left with a negative 4v equals, same sign, add and keep, 4 plus 8 is 12, and they're both negative. Okay? So now, I'm in my one-step equation. Remember what we talked about in one-step equations? If we see a number next to a variable, what operation does that imply? Multiplication, right? So to get rid of this negative 4, I have to do the opposite, which is to divide. The opposite of multiplication is to divide. So this would be my inverse. Whatever I do to one side, I got to do the other side. Okay, my division property of equality. And I got v is equal to negative divided by a negative is a positive. 12 divided by 4 is 3. Okay, so I get v equals 3. Now we could check the original equation, see if this works. Okay, so if I get rid of this for a second, if I plug in a 3 here, follow the order of operations now. What do we do first? Is it 8 minus 4 first, or this negative 4 times 3? Well, order of operations, we do multiplication first, so we'd move in this guy over here. We'd have 8, and then what's a negative 4 times 3? Negative 12. So we'd have minus 12 equals a negative 4. Okay? Now I have 8 minus 12. Different signs, positive and negative. We subtract. 12 minus 8 is 4. And keep the sign of the larger value, which is negative. So, do we get what we want? Yep. So this is my answer. Okay? Number 4. So again, one of the most common situations that you'll run into, we want to get the b by itself, so we're going to deal with the addition subtraction part first, the number furthest away from the variable on the same side of the equation. So notice we have a minus 8, so how do you get rid of a minus 8? You add, right? The opposite would be to add 8. So that would be my inverse here, but whatever I do to one side, I have to do to the other side, the addition property of equality. And I get a negative 5b is equal to, what's a negative 58 plus 8? Well, we have different signs, so we subtract, right? We subtract and we get 58 minus 8 is 50, and keep the sign of the larger value, which is negative. So again, I'm in my one-step equation now. I have a negative 5 times b. How do you undo a multiplication? Division. So we're going to divide by a negative 5 to move it to the other side. Whatever I do to one side, I do to the other. My division property of equality. Cancel these guys out, and I get b is equal to, what's a negative divided by a negative? Positive. So I get 50 divided by 5 is 10. Now plugging it back in and checking, if I plug my 10 back into here, let's see if this works. Remember, in order of operations, we do the multiplication first. So I'd have a negative 8. What's a negative 5 times 10? Negative 50. And we want to see if that's a negative 58. Well, notice I have same sign, add and keep the sign. 8 plus 50 is 58, and keep the sign, which is negative. So is that what I wanted? Yes. So I get b equals 10. Okay, so those are the most common type that we want to feel comfortable being able to work. Okay, now the last thing here is when I'm dealing with these guys. These are not as common, but they do occur, and they do count as two-step equations. Now, personally, I would work this differently than a two-step equation, but it doesn't hurt to know it as a two-step. Okay, so let's look at number 5. Okay, number 5, I'm dealing with a fraction. Okay, well, when we're dealing with a fraction, the best thing that we want to do is get rid of the fraction, right? Make it a lot simpler, make it a lot easier. So if I want to get rid of this fraction, this division by 5, what is the opposite of dividing by 5? Multiplying by 5, right? The opposite of dividing by 5 is multiplying by 5. That would be the inverse. But if I multiply by 5 to one side, I have to do it to the other side. Multiplication property of equality. So 5 times a negative 2 is negative 10. My inverses cancel out, and I'm left with x minus 5. Okay? Now, I'm in a one-step equation. I need to get x by itself and move minus 5 to the other side. What's the opposite of minus 5? Plus 5. So I'm going to add 5 to the other side. My inverses cancel out, and I get a negative 10 plus 5. Different signs, subtract and keep the sign of the larger value. 10 minus 5 is 5, and 10 is the larger value, and it's negative. Okay, so I get a negative 5 equals x. Well, let's check to see if that's right. So if I plug my negative 5 back in for x here, and going back to the original equation, okay, oops, I would have a negative 5 minus 5. Well, same sign, add and keep the sign. 5 plus 5 is 10, and they're both negative. So I'm going to write this out here. We'd have a negative 2 equals a negative 10 over 5. So a negative 5 minus 5 is a negative 10. Well, now I have division. What's a negative divided by a positive? Negative 10 divided by 5 is negative 2. So that's what I wanted, so we know that this is correct. Okay? Last situation that you could run into, not as common, but it does happen, is this guy here. Now remember, I told you guys, anytime we have a parentheses and some number in front of this, that does imply multiplication. However, we don't just have a number now. Now we have something inside the parentheses. And you're thinking, well, Mr. Pinkstrauss, don't we normally do the parentheses first? Yes, but remember, we're trying to solve. In solving, we actually work backwards. So I'm not going to deal with this parentheses until I've already dealt with the multiplication part, okay? So let's go back here. Let's take care of the multiplication part first. So I have 7 times 8 plus x. And I want to undo that multiplication, so I'm working backwards. How do I undo a multiplication of 7? Divide by 7, right? So we're going to divide by 7 to the whole side. We're going to divide 7 from the whole side so that these guys cancel out. So remember, multiplication by 7 and dividing by 7 are opposites, so these guys cancel out. But if I divide by 7 to one side, I have to do it to the other side. So I'm left with 8 plus x in that parentheses, okay? Now, we don't have to write the parentheses at this point because there's nothing else happening. So I'm just going to actually drop the parentheses, okay? So at this point, we have nothing else there. So all we're left with is 8 plus x, okay, is equal to 140 divided by 7. Well, here's a little trick to help you. What's 14 divided by 7? 2. So if I have 140 divided by 7, add a 0 to it, that would be 20, okay? Well, now I'm in my one-step equation again. I need to get 8 to the other side. Notice this is a positive 8. I know we don't have a plus in front of it, but it's a positive 8. So if I want to move it to the other side, the opposite would be to subtract 8. So I need to subtract 8 to the other side. My inverses cancel, and I'm left with x is equal to 20 minus 8 is 12. So then plugging it back in and checking here, if I plug in 12, okay, what's 8 plus 12? 20. 20 times 7? 140. Okay, so x equals 12 is my answer.